Hey guys, so in this lesson we're going to be reviewing angles of a polygon. So if you haven't already, there is a worksheet that goes along with this video on Google Classroom. So if you haven't printed that out already, you should do that. Okay, so first we want to define a regular polygon. So a regular polygon is a polygon that's both equilateral and equiangular. Okay, so equilateral means all sides congruent. And equiangular means all angles congruent. Okay, so in this next part of the lesson, we're going to be working with regular polygons. Okay, so we're going to spend some time filling in the following chart. So we're trying to discover the sum of the interior angles for specific polygons, and then we're going to find the measure of just one of the interior angles. So to do this, we know that there's 180 degrees in a triangle. So I'm going to divide each polygon up into triangles, okay? So in this first example, we have a figure with 4 sides. We have a quadrilateral. Okay, so if I start at any one vertex, I can easily divide that quadrilateral into 2 triangles. Okay, so this first row we already filled out for you. So the number of sides is 4, it's a quadrilateral. The number of triangles formed is 2. So 180 degrees in a triangle, if I multiply that by 2, we get 360 degrees. So that's the sum of the interior angles. And then if I take that sum and divide it by the number of angles, since there's 4 of them, we know every angle measures 90. All right, let's go to the next example. So in the next example, we have 5 sides. So we have a pentagon. Okay, and now we're going to divide the pentagon up into a minimum number of triangles. And it doesn't matter what vertex you start at. So you could start at any vertice. And I'm going to divide this shape up into a minimum number of triangles. So we get 1, 2, 3 triangles are formed. Okay, so if we do 3 times 180, we get 540 degrees. Okay, so now we're going to take that sum, 540, and we're going to divide it by the number of angles. So a pentagon has 5 angles. So the measure of each one is going to be 108 degrees. Whoops. Sorry about that. Okay, next shape has 6 sides, so that's a hexagon. So again, doesn't matter what vertice I start at, and I want to divide this up into the minimum number of triangles possible. Okay, so we get 1, 2, 3, 4 triangles are formed. So 4 times 180 is going to be 720 degrees. So we know that the angles in a hexagon always add up to 720 degrees. So now if I take that sum and I divide it by the number of angles, we get 120 degrees. So every angle in a hexagon measures 120 degrees. Okay, so this next figure has 1, 2, 3, 4, 5, 6, 7 sides. So 7 sides, we call that a heptagon. Okay, sometimes it's also referred to as a septagon. All right, so I'm going to come over here. We're going to divide it up into a minimum number of triangles. So we get 1, 2, 3, 4, 5 triangles. So 5 times 180 is going to give us 900 degrees. Okay, so 900 divided by 7. That doesn't work out to be a nice number, so I'm just going to approximate it. So that's approximately 129 degrees. So every interior angle of a heptagon is approximately 129 degrees. Okay, and then the last figure has 8 sides, so that's an octagon. Okay, so we're going to divide this up into triangles. So we get 1, 2, 3, 4, 5, 6 triangles. So 6 times 180 is 1,080 degrees. So all the angles in an octagon add up to 1,080. Okay, so if I take that number, divide it by the number of angles, which there's 8 of them, every angle measures 135 degrees. Okay, so hopefully by filling out the table, you do recognize a pattern. All right, there is a relationship between the number of sides and the number of triangles formed. Okay, so hopefully you recognize that the number of sides, if I subtract 2 from that, that gives us the number of triangles formed, right? An octagon had 8 sides, it has 6 triangles. Septagon had 7 sides, it has 5 triangles. Hexagon has 6 sides, it has 4 triangles, and so on. All right, so if you go to the last page of this packet, to find the sum of the interior angles, it's always going to be the number of sides minus 2 times 180 degrees. Okay, and n represents number of sides. Okay, so then at the bottom where it says, how do you find the measure for one interior angle of a regular polygon? Well, you're going to take the sum, n minus 2 times 180, and divide it by the number of sides. Okay. All right, now we're going to take a look back at the second page of this handout. Okay, so in the second page, here we want to find the exterior angle, okay? So we know that the exterior angle is formed by extending any side of the polygon. Okay, so in that first shape in our quadrilateral, we said that the interior angle was 90 degrees. And then we know that our interior angle and our exterior angle are supplementary, right? Because they form a straight line together. So once we know the measure of the interior angle, I can easily find the exterior angle by subtracting it from 180. So we know that every exterior angle in a quadrilateral is 90 degrees. Okay, so now to find the sum of the exterior angles, I'm going to take the number of sides, which there's 4, and multiply it by 90. So we get 360. All right, so let's do another example. So in our pentagon, we said that every interior angle measured 108 degrees. So this angle is 108. So again, the exterior angle is formed by extending one of the sides of the polygon. And the interior angle and the exterior angle are always going to be supplementary. So if I do 180 minus 108, we find that the exterior angle measures 72 degrees. Okay, so now I'm going to take my exterior angle, multiply it by the number of sides. So 5 times 72, the sum of the exterior angles is 360. Okay, so in our hexagon, we said from the previous page that the interior angle was 120. And now we're looking for the exterior angle. Okay, so my interior angle was 120 degrees. My exterior angle is going to be the supplement to that. So 180 minus 120 is 60 degrees. And then if I multiply that by the number of sides, 6 times 60 is 360 degrees. Okay, so hopefully by now you notice a pattern. You should notice that the sum of the exterior angles is always going to be 360 degrees. For any polygon, the sum of the exterior angles is always 360 degrees. All right, we'll fill in the last two examples. So this one was our septagon. So keep in mind that with the septagon, it didn't divide evenly, so we rounded a little bit. So we said the interior angle was 129. So to find the exterior angle, 180 minus 129 is 51. And then there's 7 sides or 7 angles. So this one, again, because we rounded, we're getting an answer of 357. But if I were to keep all those decimals in the calculator, I should get 360 degrees. Sorry. Okay, and then the last one was our octagon. So in an octagon, we said the interior angle was 135 degrees. So the exterior angle, 180 minus 135 is 45. And an octagon has 8 sides. So 8 times 45 does give us 360. Okay? So now on the last page, if we go back to that chart, the sum of the exterior angles for any polygon is always 360 degrees. Okay, so to find the measure of one exterior angle, you're going to take 360 degrees and divide it by the number of sides. Okay, and then remember that the interior angle and the exterior angle are a linear pair. So keep in mind that they're always going to add up to 180 degrees. So if you know the interior angle, you can easily find the exterior. If you know the exterior angle, you can easily find the interior. All right, so I hope this was helpful. I'll probably be posting another video with a couple of practice questions to go over with you, and then I'll leave a couple of practice questions on Google Classroom for you guys to try with the solutions posted.